So everyone, this is the extension of the Make It Rain that you did in class. What we're seeing now is the water flowing down the stream table, and just like you had in Make It Rain, your fingers were carving up the land. Now we can see actual water carving up the sand in our table.
Yeah, you noticed it started out as a sheet, so it just went right over it like you throw a blanket over the dirt, and that's called sheet erosion. And now you can see it's starting to dig down into the dirt a little bit, which is forming these little lines called rills, just like in your Make It Rain.
And the more it rains, the more water moves. Those rills get deeper. We can call them then gullies. And you can see the water's following the easiest path, like we said, from the high point in the mountains or a lake to the low point, which is,
well, whatever the low area is. It could be a gulf, it could be an ocean, could be a lot of things.
So right now we can see that there's really two main branches forming. There's one down the right and there's one on the left. You can see the right stream is pretty much curved, while the left stream is more of a straight channel. As it keeps raining here and the water keeps moving, we can see that that right stream is starting to curve out more and more as time goes on here. And we can kind of zoom in on that right stream, and when we have a curve in a stream, we call it a what?
A meander. And meanders are basically areas where you have water flowing at one speed on the outside of the stream and one speed on the inside of the stream. And if you look very closely, you can see what's happening with regard to that.
So in this little clip of the stream moving, we've zoomed in on that meander there, and we can see that the outside of the curves move faster than the inside of the curves. So if you're building a house and wanted to live somewhere, you probably want to be somewhere where the land wasn't eroding away.
Right, so on the outside of the curve with fast-moving water, with fast-moving fluids in general, you get more pickup. So you're going to get erosion on the outside of the curve and deposition on the inside of the curve, where the water slows down and drops its sediment.
And so near the beginning of the streams, like we said, there are multiple gullies and rills that form and go into a stream, and we call those little branches tributaries. So here's a zoom in of those tributaries.
You can see on the right hand side of the picture now that there are little streams flowing into a larger stream. Those are your tributaries. They're carrying water to the main part of the stream.
And as we've been moving along here, you can see that that right stream that we focused on with the meander and the curve is actually kind of dried up. It looks like the left stream has kind of taken over. What's going on?
It sure has. Well, the lay of the land has dictated that the water flow from those upper tributaries are starting to move towards the left side of the screen. So that must be a lower lying area. The water's moved over there, and basically that left-hand stream has pirated the water from the right hand of the stream.
So the right-hand stream is now pretty much dried up. There might be a little bit of water flowing through it, but it's not cutting like it used to. That was curving very, very prominently in the beginning, and we don't really have much of a curve now on the right stream. The left stream has a big curve up here at the top, so there's lots of erosion along this upper edge, but now it's got a very deep, wide channel.
It sure does, and it seems to get more and more prevalent the further down the stream you get, which is basically what should happen because you're getting more and more water as you get further and further down the system.
And so when we get near the end of the stream, so the beginning of the streams are very skinny and narrow. They start to widen as you get more mature. But what's happening there at the bottom?
Well, what's happening there at the bottom is you're kind of getting, what would we call it? A bottleneck of sorts, where the streams are starting to get choked off by all the sediment that's being carried down there. And so when that happens, the main part of the stream splits off into different sections and kind of becomes like tributaries, but the opposite direction, which they call distributaries.
So tributaries feed a stream, where distributaries kind of disperse all the water into their final location.
Right.
And we call those distributaries, those large areas that have lots of sediments, lots of fertile sediments, we call them deltas.
Yes, we do.
So some of the final things you can see as the stream table is kind of wrapping up here. We've got a very prominent stream channel from the top right all the way down that left channel. The left channel is actually starting to meander. I can see a slight curve here as time goes on, and the same process that was happening in the right stream with the fast moving outside and the slow moving inside makes rivers meander, makes them curve and move throughout their lifetime.
It does take a really long time. We are time-lapsing something that's already time-lapsed. This takes hundreds of years in some cases to develop streams, and we're doing it in 20 minutes if you're using the stream table and 5 minutes if you're using this particular video. So it takes a lot longer, but it still gives you the general idea.
And so what I've done here at the very end is I've turned off the stream table and let the water dry up. And if you kind of look over the land, when the water stops flowing, we can actually see kind of the areas that have been affected. We see the channels that are left behind. We can see the cuts. And these features we see definitely on our own planet. But where else do we see this?
We see this on Mars, actually. There was a time, they believe, from evidence like this, that Mars had water running across its surface. And it did the same thing.
So if we see the same features on Mars, we can make the assumption that we did have water flowing on other places in our solar system.
Yes.
All right, we'll talk to you next time.
Goodbye.